Today we'll be looking at something very important on the subject of statistics. The other day we treated the meaning of statistics for easy comprehension. But today we'll be looking at 4 levels of measurement in statistics. Why is this very important? It is very important because if you don't understand the levels of measurement in statistics, you will not know the statistical tool you will use per time. So when you understand the various levels of measurement, you'll be able to know which of the statistical tools, both in descriptive and inferential statistics, you can use to tackle any problem per time. So there are 4 major levels of measurement in statistics, and these are nominal, ordinal, interval, and ratio. These levels of measurement have confused a lot of people. So that is why I want to give a very clear explanation to these 4 levels of measurement. So what is nominal level of measurement? Nominal level of measurement categorizes data without any specific order. It is mainly used for identification. An example of nominal data is gender. When you talk about gender, we have either male or female. That is category. There is no order whether male is greater than female or female is greater than male. All that nominal data does is to categorize. We also have like blood group, where we have blood group A, blood group B, blood group O, blood group AB. So that is a nominal data. So in this case, you can't say that blood group A is better or greater than blood group B or O or AB. All that nominal data does is to categorize. We also look at, let's say, socioeconomic status, where we have the high socioeconomic status, the middle, and the lower. So here it is just being classified. There is no rank or order attached to nominal data. It only categorizes, it classifies. This one belongs here, this one belongs here, and that is all. Also, when you talk about race, whether the black or the white, that is just categorization. When you talk about culture, different types of culture, like in Nigeria, Yoruba culture, Igbo culture, Hausa. So that is just categorization. That is what nominal data does. And the statistics that can be used with nominal data includes mode. Mode talks about the most occurring. And also we have frequency. We want to know the number of people that are in that particular category and the number of people that are in the other category. Let's say male and female. So if you are categorizing your data or your sample into male and female, how many people are in male, how many people are in female? So frequency distribution can be used with nominal data. We can also use chi-square test. That is because chi-square test majorly works with frequency. So these are the levels of statistics that you can mostly use with nominal data. So don't forget, when you talk about nominal data, it's all about categorization, identifying one group from the other. So let's move on to ordinal data. So what is ordinal data? Ordinal data is a progression of nominal data. In nominal data, we talked about the fact that it only categorizes without a specific order. But when you come to ordinal, there is an order or rank attached to that your data. So let's say in school setting where students write exam, one take first position, another person takes second position, third position, fourth. So that is rank, that is order. So you know that this one is higher than the other. First position is higher than second position position is higher than third position position is higher than fourth position. So that is ranking. And also in military, we talk about rank. So whenever you hear ranking, they are talking about ordinal data. So it is a higher level of nominal. And apart from frequency distribution, mode, and chi-square, another level of statistics that can be done with ordinal data is median. In ordinal data, you are able to calculate the median. You can also calculate the percentile and other non-parametric tests. So that is about ordinal data. But one thing I would like you to know about ordinal data, you will not be able to distinguish the difference between one level and the other. For instance, if somebody takes first position, another person takes second position, we are not able to distinguish the marked difference between these two positions. For instance, if somebody scores 80 and another person scores 79, definitely the person that scores 80 takes the first position and the person that has 79 takes the second position. So in a situation whereby maybe somebody scores 80 and the next person scores 60 or 40, that person still takes second position. So you are not able to distinguish a difference between one level and the other. All you know here is that one is higher than the other. So you can see that this one is higher than nominal data, but it still has some limitations. So let's proceed to the next higher level, and that is interval level of measurement. Interval level of measurement. When you talk about interval level of measurement, it is able to categorize data. Number one, there is an ordering. One is higher than the other. That is number two. And then the additional level in interval is the fact that you are able to distinguish the difference between one data and the other. For instance, when you look at measurements like temperature, if one is 0 degrees centigrade, another one is 2 degrees centigrade, another one is 4 degrees centigrade, you are able to know that between this one and this one there is a difference. So there is an equal level of difference in interval level of measurement. We also talk about something like IQ scores. Let's say somebody scores 16 in IQ, there's another person scores 61, 62. So there is a clear marked difference between one level and the other in interval level of measurement. So what are some of the statistical tools that can be used with interval level of measurement? You can use mean, you can use median, you can use standard deviation. You can also use interval data to calculate Pearson correlation. So interval data has the ability to accommodate Pearson correlation, unlike ordinal data. Ordinal data, you cannot use it to calculate Pearson correlation, but you can use it to calculate statistics like Spearman rho. The shortcoming of interval level of measurement is the fact that it does not have a zero origin. So because there is no zero origin, you are not able to distinguish the ratio between two measurements. Yes, you know that between IQ score 60, 61, 62, there is two scores in between, but you are not able to know that, okay, this person is 2 times intelligent than this other person, or this person is 7 times duller than this person. So it does not have the ability to accommodate such ratio whereby you can do some multiplication effect. That is a limitation with interval level of measurement. But please take note of the fact that interval level of measurement is higher than ordinal and it's also higher than nominal. So let's take the last level of measurement, and that is called ratio. So in ratio level of measurement, apart from categorization, apart from ordering, apart from equal distance between variables, interval level is able to have ratio level. Ratio level of measurement has a zero origin. So that zero origin helps you to know that one level of measurement is 2 or 3 times higher than the second one. For instance, let's look at things like height, weight, age. Practically look at age. If somebody is 2 years old, and that person is 4 years old, and that person is 6 years old, you'll be able to know that this one is 2 times the age of the other person. We also look at something like weight. So if somebody is weighing, let's say 6 kg, another person is weighing 12 kg, another person is weighing 18 kg, so you know that the person weighing 18 kg, the weight is 3 times more than the person that is weighing 6 kg. So it has that zero origin, and that gives it more capacity to accommodate some statistical calculations like t-test and ANOVA. So with ratio level of measurement, we can calculate things like t-test and ANOVA and coefficient of variation. So, and all descriptive statistics can be calculated with ratio level of measurement as well. So that is it about these 4 levels of measurement. I hope you understand what we have just talked about. We talked about nominal level, which is basically about categorization, like male and female. We talked about ordinal, which is ranking. For instance, excellent, very good, good, poor. So that is just ranking, but you are not able to get a clear difference between one and the other, but just that you know that one is higher than the other. Then we'll talk about interval, where you are able to have a clear difference between one measurement or one score and the other. For instance, things like IQ. So those ones, you can accommodate them. And then also we talk about ratio, and ratio has true zero origin, so it allows for ratio comparison. So if you understand these 4 levels of measurement, it will help you so much in your statistics, because when you are presenting with a particular problem, you'll be able to know which one fits in to a particular calculation or not. If not, you may just be wondering, with this question, what can I use to solve it? What can I use to sort it out? How do I go about it? But with this understanding, you'll be able to find your way out. So if you don't understand it very well, maybe you can watch this video, comprehend it very well. If you have any question, you can drop it in the comment section, and I will respond to the comments as fast as possible. Please, if this video has helped you in any way, don't forget to like, subscribe, and comment. And much more videos will be dropping on this channel, especially on the subject of statistics. And I know that you will always be helped through those videos. Thank you once again. See you in our next video.